Chapter 2, Section 4.
Other types of equations. Other types of equations is defined as absolute value, radical, and fractional equations. First, we have absolute value. Absolute value equations are defined as if c is equal or greater than 0, then the absolute value of c equals c. For an example, we have the absolute value of 2 equals 2 because 2 is a positive number. And on the other side, we have the absolute value of negative 5 equals 5 because when counting for absolute value, negatives don't count. Absolute value can be interpreted as distance when looking at a number line. If you count the distance between negative 2 and 2 on a number line, you can see that there is 4 spaces, and the difference between them is an absolute value of 4. Now, if c and d are real numbers, then the absolute value of c minus d is the distance between them on the number line. However, when d equals 0, the distance from c to 0 is the absolute value of c minus 0 equals the absolute value of c. That's exactly as redundant as it sounds. If c is a real number, then the absolute value of c is the distance from c to 0 on the number line. That means if c is a number, it equals itself. Don't you love math? Now, if you want to simplify absolute values, you have some properties that might help. I mean, they're all basically repeating things you learned in 4th grade, but they're better than nothing. The first is, the absolute value of c is equal or greater than 0, and the absolute value of c is greater than 0 when c does not equal 0. The absolute value of c is equal to the absolute value of negative c. Third, the absolute value of cd is equal to the absolute value of c times the absolute value of d. And finally, we have the absolute value of c over d equals the absolute value of d over c when d does not equal 0. Next up, if any c and d are any real numbers, then the absolute value of c plus d is less than or equal to c plus the absolute value of d when d does not equal 0. Or, when c is a positive number, then radical c squared equals c, but not when c is negative. For every c that is a real number, radical c squared equals the absolute value of c, because obviously a radical and a second exponent do the same thing, so they cancel out. It's really that easy. Now, a lot of absolute value equations can be solved with definitions. Some geometric, others algebraic, and you can check them all with graphing. The examples provided by your textbook are lame, so feel free to ignore most of them. You probably know how to count, so using absolute value to figure out distance should be easy. You've known how to count from 1 to 10 for a while now, since 10th grade if you're my brother. Or, if you want to deal with extraneous solutions, all you have to do is check with graphing. But solving an equation requires a bit more work. We'll do the absolute value of x squared plus 4x minus 3 equals 2. We'll factor because it's simpler, but you can use the quadratic formula if you prefer. Once you've factored, you should get x squared plus 4x minus 5 equals 0. A little more factoring, and you get x plus 5 times x minus 1 equals 0. And finally, you get x equals 5 and x equals 1. Oh, I'm sorry, that should be negative 1. But once you graph for your solutions, you'll see the answer is x equals 1. Next up, we have radical equations, and I'm sure you're delighted to be on this adventure of a math course. Radical equations contain expressions with variables under radical symbols, and if you want a precise answer, you'll have to do it algebraically. The method of doing so algebraically relies on if a and b are algebraic equations, and a equals b, then a to the nth power equals b to the nth power for every positive integer n. For example, if x minus 2 equals 3, then x minus 2 squared will equal 9. Next up is the power principle. If both sides have the same positive power, then every solution of the original equation is a new solution, but the new equation may not have the same solutions as the original. Because I know everyone loves listening to more examples, Try this one. 5 plus radical 3 minus... 5 plus radical 3x minus 11 equals x. After you isolate the radical on one side of the equation, you have 3x minus 11 equals x minus 5. Little more factoring, and you get x equals 4 and x equals 9. Graph for extraneous solutions, and you will get x equals 9. Finally, we have fractional equations. If f of x and g of x are algebraic, then the quotient of f of x over g of x is called fractional, which means the denominator, g of x, cannot be 0. To solve fractional equations, we use the principle f of x over g of x equals 0. The values must be that f of x equals 0 and g of x does not. For the last example, the textbook gives us to solve 6x squared minus x minus 1 equals 0. Now we factor, and we get 3x plus 1 times 2, x minus 1 equals 0. Going from there, we have x equals negative 1/3 and x equals 1/2. So, if you check your solutions, you'll find that x equals negative 1/3 is our answer, and x equals 1/2 is extraneous. Do you feel like we just went through the 9 circles of Dante's Inferno? Probably, but we're done for now. So you can do all these exciting math things with this new knowledge, like, nothing. Absolutely nothing. Oh, nothing. But hey, passing grade makes it all worth it, guys, right? Right? Right?